Hello everyone in CIS-115. We are starting week 12 of the class, and that is also a new module, Module 6, which covers list. Lists are very, very powerful. They do some things that we can't do with strings. So lists are similar to a matrix or a set if you're familiar with math. So let's talk about the difference between list and strings. The good news is that a lot of what we learned in strings also applies to list. But there are things that we can do with lists that we couldn't do with a string. So let's kick the tires on some of those things that we can do with lists that we can't do with strings. So first off, here's an example. Here's an example of what we can't do with a string. I'm going to set up a variable. I'll call it a string. And let me make the font size bigger just in case there's folks out there that are having a little bit of a hard time seeing the seeing what we're doing. So, okay, a string equals, how about this? A, B, C, D, E, F, G. Okay. So at that point, we have a string that consists of those letters. This is something I can't do with a string. A string, square bracket, 0. Those of you that remember string indexing from last module, the 0 character in the string, if we're using that indexing, that equates to the A. So let's try to change the A to a Z. Okay, so we have this string that starts off with A, and then has all these other letters in it. I'm trying to change this A, which is at an index of 0. I'm trying to change it to a Z. Do you think Python's going to let me do it? Well, let's just see. What's it say? String object does not support item assignment. That's because strings are immutable. We just proved that strings are immutable. What does that mean? It means we can't change them once we create them. Once we made this string, it's set in stone. We can't change an individual piece of it. We could change the whole thing, but we can't change just one letter or several letters in that string. That's because they're immutable. Lists, on the other hand, are mutable, which means we can change them. So I'll comment this line out here that was blowing. Okay, so those two kind of go together. All right, so let's make a list. Let's make a list of those letters. Okay, so here we go. A list equals, list function will convert a string into a list. So let's see what's in this list once I've done that. Okay, clear my shell, run it. See, here's what my list has in it. I just printed my list, and you can see it has these elements in it. This is A list 0 right here, A list 1, A list 2, A list 3, A list 4, A list 5, and A list 6. And everything that you learned about string indexing applies to list. It works just the same. String slicing, just the same. Okay? You remember I could get how long a string was by doing this up here where we have our string, a string. I could do this. The length of a string is, use the length function to get that. So when we run that, you can see right here, there's where I did this line right here, and it's printing out the length of a string is 7. 1, 2, 3, 4, 5, 6, 7. Okay, so anything that we could do with a string, we can do with a list. So right here, let's just try that same function out. The length of a list is, okay, the length of a list is 7. All right, you remember when we tried this with a string, we got a traceback error and it blew? Okay, well, I'm going to comment some of these other prints out so that we don't have too many prints going on here. So let's try the same thing with our list now. I want to change, let's just print it again. This is what's in my A list right now. See it? So the A is at index 0 because we index things starting with 0. So let's try to change it. Okay, A list square bracket 0, just like we were trying with the string, equals, let's try setting it to a Z. You remember this blew. Okay, let's see if we're able to change it. Here goes. You ready? What's it got in there now? A Z. So we just proved that lists are mutable in Python, which means once you create a list, you can change the individual pieces of it. So you will have questions about this, and of course we'll be changing things in the list as well. So back to the checklist here. Okay, so list is an ordered sequential collection, okay, just like a string, but as we just proved, lists are mutable, which means we can change the individual pieces of them. We can't do that with strings. Okay, now what's really cool about list, and I can't do this in other languages, with a list in Python, we can have one element that's a string, one element that's a float, one element that's an integer. You heard that, right? All these different types, and we can do that in Python. We can't do that in other languages. So let's just try setting up one. We had a list here, and it had Z, B, C, D, E, F, G. Let's add another element to that list, here's how you do it. A list dot append. Okay, so we're going to append something onto the end of that list. So I'm going to append 100. I'm going to append this integer 100 onto the end of that list, and then I will print it. I'll cut that and I'll paste that print down here. Okay, so let's see what's in that list after we append 100 to it. See what happened? We just added an element to the end of this list, and it's an integer. We could have an element on the end of that list that is a string. So append, this is a string. Okay, so now look what we have now. We have all the things that we had before. We have the 100, and we have an element that has a string. So you can see I've got three different kinds of things here. These are characters, this is an int, and this is a string, and all of them are in one Python list. Can't do that in other languages. In other languages, really our lists are called arrays, A-R-R-A-Y-S. And in like C++, if I wanted to create an array, that array has to be all the same thing. If I wanted an array of characters, I couldn't put a string in that array. If I wanted an array of characters, I couldn't put this integer in there. Okay, so they all have to be the same type in other languages. In Python, it doesn't care. You can have characters, ints, strings, doubles. You can even have another list inside of a list. So pretty powerful. You heard me say that, right? You could have a list that's an element of a list. So right here, if I go back, the way we make a list in Python is with the square brackets, and then you can tell it how many things are in there. So let's do this. 1, 2, 3. I put three elements in this list that I'm going to append. Okay, and let's just go ahead and leave that string there as well. We had a string on the end of it. Okay. Alright, here we go. Look what I have now. I have characters at the front. I have an integer. I have a string. And I actually have a list inside of a list. Wow. Pretty neat. Pretty powerful. Okay. So here's our list lecture. Where am I getting that? Here's our checklist. You see this item right here and right here, this is linked. Okay. So we'll talk about this list lecture, but just so you know, most cryptocurrency uses a special type of a list called a linked list. And linked list, and in particular the blockchain, is going to change everything we do. We'll get into this more next week, but it fundamentally changes not just money, birth certificates, student records, transcripts, you name it, health records, everything. This blockchain stuff that Bitcoin uses can completely change the way your driver's license, your driving record, your deed to your house, titles to cars, you name it. The blockchain can change all that. So that's why we cover it. We're not covering it so much because Bitcoin, although Bitcoin is very neat, I mine Bitcoin, but that's not the reason that we cover this linked list and blockchain in this class. The reason is because blockchain is going to change everything. It already has started. Okay, so here's the item, the list lecture that we're going to go through some of the items here in the list lecture. So I've already got it open right here. And we'll scroll up to the top of that list lecture. Okay. And this starts out by, you've heard me say this 3 times now. They say something's important if you hear it 3 times. So lists are mutable, strings are immutable. That's the 3rd or 4th time that I've said that. So do you remember all the stuff that we could do with strings? Well, guess what? We could do it with lists. Indexing, same way it worked in strings. Concatenation, which means combine 2 things together, works the same as it did with strings. Repetition works the same as it did with strings. We can repeat things in a list. Membership. If you want to know something is in a list, we could use the in operator. And of course, you could do the negation of that. So what do I mean when I say this membership stuff? Well, if we go back over here, okay, and we looked at this list right here that had this stuff in it, if we wanted to know if 100 was in that list, we could find out by using the in. Let's just try it here, okay? I'm going to print 100 in a list. Let's see what happens. It'll be the last thing that prints down here in our shell window. What's it say? True. That's because 100 is in that list. Remember? We added it right here. Let's print it again so you can see. Okay. Here's our list right here. I ask it if 100 is in there and right here on this line, and Python came back and said, yep, that's true. Okay. So, membership. We already did this length stuff. I already showed you that. Slicing works the same as it did with strings. So let's see if we could slice something out of this long list that we have here. Okay. Let's see if we can slice something out. How about I want the first 3 letters, or first 3 elements of that list? Well, right here, I could do it with my square bracket. There's my square brackets. If I wanted to start at the first element of the list, that's 0, and I wanted to grab the first 3, okay, you tell it where to start, you tell it where to stop, okay? So let's tell it to stop at 1 before 3. So let's see what that prints out now. What did I get? ZBC. Remember, it stops at 1 before that number. So it said, give me this, this is 0, this is 1, this is 2. So I sliced that out. And those of you that remember string indexing, If you've got a 0 here, you don't actually have to put it. You can actually do the shorthand way. Like I just left the 0 out and I have the colon there and the 3. And you can see that gives me exactly the same thing. Okay? So that's slicing. Min and max. Now, if you've got a list that has multiple types of things in it, that's probably not going to give you the answer that you want. Okay, we could try it and see what it does here on our A list that has all these things in it, but I think it may even give us an error. Let's try it. Okay, see what it says? There's our error because we have multiple kinds of stuff in here. Okay, if we wanted to make it all one type of thing in the list, okay, let's do this. I have made it now all characters again. Let's run it now. Now that it has all the same thing in it, here's where I ran the max, and instead of blowing, it actually gave me the Z. Z is the highest letter in there, isn't it? Okay, so that's our max function. Okay, really cool. You have a sum function. If you had a list of all numbers, it would add them up for you. Okay, it would add all those numbers up. Let's try it here. We'll create a list. A number list equals. Okay, this is a way you can construct a list. Your square brackets. Let's just say 10, 20, 30. And believe it or not, the sum will work if you have a list that has ints and floats in it. So print sum a number list. Okay, let's see what the sum of adding all these numbers together is. 105.999. Pretty neat stuff. Saves you a lot of work. Okay, here's some of our methods that we have that are available to us. We'll come back and talk about those. Right here we have defined a list named Li, and we've said it's going to have A, B, this string M Pilgrim, a Z, and an example. So if we look at that, here's what we would have with our indexing going on. Element 0 is the A, right? Element 1 is the B. Element 2 is this string M Pilgrim. Element 3, using positive indexing, is a Z. And element 4 is example if you're using positive. You remember with string indexing, we could go at this negative with a negative index. If you had this in your program, which we can copy that and paste it into Python and try it out. If we had this list in our program and I wanted to get the last thing in the list, it's always a -1. So we'll go back and try that. Okay. So we'll get rid of all that. Paste that in. Okay. Print Li. We're going to slice out or index out the last thing in the list. -1. Okay. That should be example when we run this. And you see it is. Okay. So I just used negative indexing to get that out. Okay. Here's how, of course, element 0 is always going to be the first thing in the list. You see it printed in A out. That's because if you go back and look, element 0 is an A. Okay? Slicing a list. Just like we had with string slicing. Let's see if we can figure out what this does right here. This says start at position 1. So it says start at B. Okay? And then it says stop at 1 before 3. So here's 3. So we should get B and M Pilgrim out. Let's try it. Okay, I'll just copy that code and paste it into Tawny. I've already got that list set up. Here we go. Well, make sure I get rid of what I want to get rid of. Okay, here we go. B and M Pilgrim, because this said start here at element 1, stop at 1 before element 3, so it's going to get this much. String slicing. List slicing. Okay? And again, the slicing shorthand, we know that if you leave something out that says start at 0, stop at 1 before 3. Okay? So if we wanted to get the first 3 elements, again, we could do that. You can see we get that out, slicing. Okay? We already did this append to add things to a list. Now, extend and append give you a little bit different. The difference between extending a list and appending to a list. Let's see. If our list has ABC in it, and then we do li.extend def, okay, that's going to append def on the end of it. But here, you saw me do this earlier. If we use an append, we're actually piecing a list into one of the last elements in that list. So there is a difference. One, the extend just kind of adds it onto the end. The append actually puts whatever, if you're using a list, it's going to actually put that list in as a new element inside of your list. So you end up with this. Okay? So we already did the searching stuff, but there are some other things that we can do. For instance, if we wanted to find out what position example was in our list, well, example should be in position 4, as you can see here. But if we wanted our program to figure that out, okay, then we could do this. If we go back, okay, right here, this is saying, tell me what the index is of example. So I can just paste that code in right here. Okay, so you can see it's at position 4, and there's position 4, and there it is. Okay, so you can see that our index gives us the number where that's found. Now that's going to be important when we look at doing our project this week or next week, because we can use that to eliminate all the if statements. If you remember the pizza program that we did, you could use that index to find where something is and use that to get to everything else if you had what we call parallel or synchronized list. So, but we'll talk more about that later, okay? So, removing elements from a list, okay? If we wanted to get rid of something from the list, you can see that if we say li.remove and we tell it to remove, we don't have new in our list, but we do have stuff that we could remove. Let's do it here. We have Z in our list. So, whoops, that's not Z. There's Z. Okay. What do you think's going to print on this line after we remove Z? It'll do just exactly what it says. See, it's gone now. Okay. Now, some other neat ones that you can use are pop. And pop, not only will it get rid of it, but it will give it to you as well. This is neat for like dealing cards out or something, because once you deal a card to somebody, it's no longer in the deck, isn't it? So you could actually use this little pop to make yourself a card program. So let's do this. If I say li.pop, okay, with nothing there, okay, what pop is going to do, if you think about this as a list of plates, when you get a plate out of the cabinet, do you get the plate off of the bottom, or do you take it off of the top of the stack of plates? I think most everybody I know of gets it off the top. So if we do a pop, it's going to take this off the top, and it'll hand it to us here where we can see it. It removes it, it returns it to us here, and then it's also gone out of the list. So here you go. Here a removed example on this line right here. You see it's gone. It's no longer in our list. So that's a pop, okay? Popping something off of the list, okay? So at this point, we know enough to do some code lab items. So let's jump into code lab here and look. Here's our module 6 code lab. First question says, write a statement that defines plist to be an empty list. Well, that's pretty easy. Plist, let's see if I can make this bigger. Okay, plist equals, how about this? That's an empty list. Could you have done this another way? Sure you could. There's a Python function to make a list. This actually creates a list from scratch. You can see it's happy with that too. Okay. List indexing. Well, we have a lot of these. Okay. Let's just do the first one here, and then we'll go down and do some others. This is saying, given that plist has been defined as a list of 30 elements, add 5 to the last element. Okay, so plist, we already know that plist lists are mutable in Python. So how could we get to the last element? -1, right? Plist -1 equals plist minus 1. It said add 5 to it. Okay, now if you're into not having to type so much, do you remember the shorthand for this is plus equals? So we could actually shorten this up to do this. And that does the same thing that I did before. Okay, let's see if I can get back to where I was right here. Okay, so how about 202? 51202. Assume plist has defined and is associated with a non-empty list. Write a statement that increases the first element of the list by 10. Well, that's pretty much what we were doing before, isn't it? plist. What's the first element always in a list? Element 0. plist, okay, says increases the value, so I can do plus equals 10, right? Okay, the last one's supposed to be the hardest. Okay, assume that we have something called playlist, and it's a non-empty list that all elements have ints in it, so it's got all numbers in it. Write a statement that associates a new value with the first element of the list. The new value should be equal to twice the value of the last element. So they're going to make sure we know how to get to the first and the last elements of this list. Playlist. The first element is what? 0. 0. Okay. Says write a statement that associates a new value with the first element of the list. Playlist 0 equals twice the value of the last element. Playlist, the last element, minus 1 times 2. You can see that that's doing what they ask. Okay. Slicing and splicing and all kinds of stuff here. Slicing and splicing. How about 611? We've got playlist 1 or plist 1, plist 2, both are lists. Write an expression that evaluates to a list. It's a concatenation. Do not modify 1 and 2. Okay, so all we're doing is concatenating the two lists together. Plist 1 plus plist 2. Okay, add them together. Last one in that section. Plist 1 has been defined to be a list with k plus 1 elements. Write a statement that defines plist 2 to be a new list that contains all the elements from index k of plist and beyond. So everything from k on. How can we do that? K on. Okay. Well, let's try it here. Plist 2 equals plist 1, and we need to slice stuff out of plist 1, right? It says start at the at k and go all the way to the end. So the last element in the list is always a -1, but let's see if we can get by with just this. Okay. Remember, if we need all the way to the end, we can just leave that out. Okay. List addition and retrieval. Addition and retrieval. Okay. So let's try this first one. plist refers to a list. Write a statement that adds another element 5 to the end of the list. What would we use based on the lecture earlier? Append, right? Append. So plist equals plist.append, and we're going to append a 5 onto the end of it. Okay. All right, let's talk a little bit about the project this week and next week. Okay, the project. So if we go to Blackboard here, I have a whole lecture that I'll do another video for. But right here in our list, you'll notice it says program to demonstrate using list with a menu. So we have a little program here, program to demonstrate list. Okay. It works very close to what was being done in the pizza program. Okay. It asks you to enter in what gauge wire. Type a 1 for 18 gauge at 30 cents a foot, and so on for the different sizes of wire. They're different costs because obviously the heavier wire is more expensive. Okay. It asks you to enter in the number that you want of whether you want 1. If you type a 1, you're ordering 18 gauge. A 2, you're ordering 14, and so on. It responds with, okay, you picked 14 gauge wire at a cost of 39 cents a foot. Next thing it does is ask them how many feet do you need. This person typed in 100. So 39 cents times 100 gives you $39. Okay, so we'll code this program. And if you understand what's going on in this, you will have no problem doing your project. And I'll do a separate video for this. But your project for this week is right here, project 9. Okay, and you can see it's got your pizza program. You will do this with no if statements. No if statements. This whole program, do you remember how many if, ELIF, and else things you had in the pizza program before? You can do it without a single if statement if you follow what we're doing in the lecture. So I'll do a separate lecture for that program. Good luck with everything this week. You should be focusing on the code lab. By the way, good news, the code lab is the last code lab of the semester. I know you're disappointed. No more code labs after Module 6. So, last code lab of the semester. focus on the code lab and focus on the homework questions that you can answer, and look for the other video on how to do this program, the wire gauge program that you can use as a pattern for Project 9. Good luck this week. Stay safe.